Hello and welcome. Um, our next presentation is about to start, and for this presentation we have Tadeh Hakopian, who is going to be talking about programming your way up Skyscraper, Python in the build world. Help me welcome Tadeh with a round of applause.
Thank you, everyone. Hope you can hear me. And by the way, if you guys want to get a preview of the presentation before I get started, if you want to catch up, I have the QR code and the tiny URL at PyArc. And I'll have it again at the end. So let's get started. A little bit about me, Tadeh Hakopian, a program manager, background in architecture, and experience with architecture, engineering, construction, using data, VR workflows. I've been teaching people about all these things, low code, Python coding for a couple of years now. And in my experience, one thing that was a big deal to me is that Python makes it possible. And this is a showcase of how Python can support architects and design in a lot of different ways. And just as we talk about these examples and I go over them, consider how you use your build space, your environment around you, how you interact with it, and consider what it takes to get there as far as the design intent and making the concept into reality and the challenges therein. So, to get started, we got architects and architects. So when people think architecture, usually, especially in this crowd, we're thinking systems, pattern languages, what have you, and that's a big part of it, right? There's a lot of people who have a CS architecture background, but there's also architecture, these examples of floor plans. And they actually have a common ground. The reason there's so much jargon shared between them is that there was a source material from the 60s and 70s from this guy called Christopher Alexander, who was a traditional architect who talked about design patterns. He's and pattern language. He's you can repeatedly use a pattern for designing a building, a floor plan, using windows in a certain arrangement that makes sense for a small building, for an apartment block, for a city. And you can just scale this up. And some computer science students picked up on this in the 70s and said, hey, this is a great idea. So they borrowed a lot of his concepts and created the idea of design patterns, which is where we get all these ideas of architecture into computer science. There's actually a lot of shared knowledge between the two groups. There's a lot of crossover appeal. So there's already a lot in common. And talk about architecture. This is what people usually think about what architects do. They think about a guy drawing on a board, coming up with ideas, being artistic, which is a big part of it. But these days, that would be more of a design sketch, whereas back in the day, they would just spend all day drawing. They only need to do 20 drawing sheets to get the whole building across, a couple of facades, a couple of plans, and you're good to go. These days, you need a couple thousand drawings to get anything done. So we moved on from this to something like this. This is kind of how we work today. It's not just a two-dimensional image. Our buildings are fully 3D realized, and not just in the plain 3D geometry. It includes the elevation of the buildings, the geometry, every single account of the doors, windows, gross square footage, volumes of the walls, and so forth. So a lot of data is embedded into how we work today. So it's not just an image or an example, it's the real data. And now that we have this data-rich format, we can have an easier time accessing it, whereas before it was literally just sketching and drawing and just not very useful data. And this system, for reference, is called building information modeling. It takes the design intent, geometry, and data and put it together into a common data environment where we can have access to all this at once and not have to have different ways of storing the information. And it's just basically a relational database. All you saw there is just tables connecting to each other. And this is how it works in the world today. We use some software. I'll just use the one that's very common just as a reference in this world of building information modeling, BIM. Revit, it's millions of people use it. So there's other ones, but we'll just use this as a reference today, which itself has the 3D modeling capability and databases. which can give you something like an elevation. It'll just create drawings. You probably, if you had been in a building of any kind that's either been renovated or built ground up in the last 10 years, that's probably how they put it together. So it's a lot more data rich and accessible than it's ever been before. But in order to access that, we need some special tools. And this plaid-looking thing here is called Dynamo. It's a low-code solution that connects the data and geometry from these BIM solutions so we can manipulate it and get some custom workflows out of it. And it's simple as this. You might have seen something like this before. Node-RED, for example, is the one that's pretty popular out there. It's just, what they call a graph of nodes connected to each other with wires. And it's basically your inputs, process, outputs, low-code or no-code solutions. And that's what Dynamo looks like. And you could use it to connect to the Revit API. And, you could do anything you want. You could do arithmetic operations. You could put two numbers together and get a result. But you can go further with it. You can actually use it for working with geometry. So you can draw a line in your model, select it here, and actually figure out things like how many points I need on a line. Especially something like this with a curve. You can just put the integers in there as a slider, have a code block, space them out, and you get a result. And you can input that in your model, which is really neat because you don't have to sit there and try to figure it out yourself and draw it out, or it takes forever. So this is really cool automation technology. And it's visual, on the spot, and you can see the results. And we can go further with it. I can create something like a floor plan. Let's say a rectangular floor plan. On the left there I have 30 feet and 60 feet. And I just tie in my X, Y, Z coordinates for 4 corners. And on the bottom there, I have my different kinds of materials. Curtain wall, and levels, how many levels I want, and a concrete slab at 6 inches. I connect the dots on that rectangular coordinate set to create my shape, and then I embed the types of equipment I want in there and materials to get some output of floors and walls and levels. And we go from this geometry preview to this result. And that's about 70 stories of a tower. So we just built our skyscraper in 2 seconds. It's that quick. If I did that manually, it would take me an hour, maybe 2. So it's pretty cool results you can do with Dynamo. And you can also do some unconventional things. You could take these kind of code blocks, use kind of a wavy pattern on your wall. You could put some art on it if you want to do something a little unique. And again, you can manipulate all of it. And you don't have to be an expert in coding to use it. And also, you can just preview geometry you want to play around with, connect things, just see how things play out, which is really neat if you're kind of into that whole touchy-feely kind of molding clay idea, which a lot of designers are. They're not too comfortable with just visual textual code. But you might be asking, this is all cool, great, but what does that have to do with Python? So I'm getting there. It also has a Python script node within it. This was my kind of gateway into the world of Python years ago. I was really wanting to use it, but I had no way of using it at work since we didn't do anything with Python for the most part, but Dynamo did have one. And it has a little IDE in it. You just import the runtime, you import the geometry library that comes with Dynamo software, and you have an input node, so you have to have a wire coming in, and you have an output node. It's a little different from your typical Python script, but otherwise very similar concept. And what's great about it, you don't have to use the API, you don't have to know anything about the SDK. You could just use this Python script plus the Dynamo to get things into your Revit database. And that API for Revit is a beast. It's not user-friendly, and it's nice to get around it. So instead of using all that, you can just run with a Python script in Dynamo. And it uses IronPython or CPython at this point as for implementation. So I can give you an example. We could just do a loop to make a bunch of stuff. And in this case, this happens all the time. With your keystrokes, you're trying to get things into your model real quick, whatever you're trying to build. So even with a low-code script, it will take me a little bit of time to create a loop because I'm saying, okay, how can I get some coordinates going on? So here's an example of a little script we have here where we just import our runtime environments, the geometry, and then also I want to write into Revit, so I have to import the Revit stuff in here. And all I'm doing is saying, whatever family I want to put in there, family being just the object you want to put in there, create some coordinates, X, Y, Z, 0, 0, 0, and give me an output list. So it's a X range at 0 to 100 feet in 20-foot increments. That's then the for loop for Y in that X range, same thing, 0 to 120, and then a Z in that range. So I get my X, Y, Zs at however many intervals and however many steps, and then I spit out a value of point by coordinates in XYZ. And I say, okay, the column is going to be the family instance times the at the point by coordinates, and then append the column to that. That's it. So that's the entirety of the effort. So I could take something like that, put it into the IDE for the script, and I push out all that. So I got, without using a bunch of like nodes and wires and all that, I have the entire geometry listed right there in front of me, which is really neat because I can hand this off to just about anybody, even if they don't know anything about coding or Python. Just change those numbers. They're good enough. It was like, yes, just use the numbers, change them, and you can figure out the rest there. So that's really easy to read. It's compact, and it's just nice because you could take that and actually push that into your model. And recently, I've done this where I had to do this exact same thing, like, I don't know, 6,000 times. And I did not want to manually do that 6,000 times or any other way. This is just a quick, like, as long as you know your range, it'll spit out everything pretty cleanly. So it's the kind of things you could do here with just some basic scripting and examples that we can't easily attain even with those low-code nodes. And you can take it further. You can put everything in the script. If you know what you want, you can just assign, say, width and length parameters, and have an origin point, have an axis, and tell it to turn the axis, and you get this cool twisting tower effect. So the Skyscraper I had before, which was like, whatever, 70 levels, if I were to use those nodes with all the strings, that would take a minute. But I could use this to just say twist it. And twist it does. And you can have a lot of fun with this. And again, it's pretty easy to read. There's nothing really crazy about that. They can get longer, of course, but these are just compact examples. This is an example of just very easy, accessible use of Python in the design world. And you can take it further. You can, like these examples are how you can do something as complicated as having these array of steel girders and beams aligned in a weird way. You can use the script to help you to create that as well. Otherwise, it'd be a bit of an effort. Some of our software is not very friendly to change. So this is great to have something like this between the low-code solution and the code solution to create geometry and that we can use for some cool projects. And you can take it even further. This example here on the link, it's this whole sample of how you make really a train station canopy with these kind of tools very quickly. So you can manipulate all the diamond shapes you see here without having to spend literally like a month modeling that the old-fashioned way. So these are the kind of possibilities we have now with Python and all these other solutions that we didn't have even 10 years ago. And that encouraged me to make my own course about it. This was a couple years ago, that I made my own course. I learned about it, I studied it, and I created my own little course about how you can do all this stuff with Python, with Dynamo in this environment, so I could show other people in the design industry how they can use it for all sorts of different purposes. And of course, like anything else with code, you do have to debug it. That's what happens when things don't work, when you have errors and warnings. You get those yellow boxes. So you're not free from errors and all that. It's part of the reality of any coding, but it's a pretty fun learning experience with this because you can see your results. Either you have some crazy shapes that shouldn't happen, or you have way too many objects or not enough. So it's kind of fun to see those results pop up in front of you. It's very encouraging. It's a very good experience for first-term learners. And you might ask, well, what about other things? What about drawings? Well, here's the thing. Everything we just saw was just the Dynamo solution, which comes with the Revit software. There's a whole community working with Python to create their own solutions. This, for example, is called PyRevit. It's a rapid application prototyping solution. The idea here is that you can, if you really want to, you can skip all that stuff with low code and Dynamo, just have this sit on top of the software. And instead of having to worry about C# and the SDK and all that, you just run with this PyRevit solution, which is built on another open source solution called Revit Python Wrapper. So the whole community out there, nobody really wants to use the SDK for Revit. That's how badly you want to get around it. It's very painful. So everybody just kind of made their own solutions. So PyRevit was its own project. The RPW, the Revit Python Wrapper, was another project, and they just put their heads together and made this. And what's cool is there's a whole toolbar that does a lot of automation for you out of the box, and you can make your own tools. And people have been doing this, using these solutions for a couple of years now. It's been great because you can take, like, inside of your software, you don't have to use the low-code environment. It's directly there. You can share it with your coworkers as an application. It's all kind of pre-packaged with batteries included for you. And it looks like this. That's the monstrous API nobody wants to use. You still have to learn how to use it. Fun story, this website here is actually another open source project called Revit API docs that somebody else made. because the API documentation that the developers released was really bad. So this guy basically put it online, and the developers then use it themselves, basically figuring out their own documentation for different versions of the software. So that's an open source solution to figure out all the code samples. And then you could use, it's kind of hard to read, but that's Python based, not C#, that you can use to create your own applications, to do cool things like edit unconventional shapes or weird shapes and things you can't do out of the box, or you have to spend a lot of money on third-party solutions. So now you can just directly edit with Python into the model, which is great. And let's say I created it, it works, I can share it with anybody else, all for free. And we also, stepping outside of all this other BIM software, we got Blender, a very popular software, general modeling. It does a lot of cool things. And it's like one of the most popular 3D modeling softwares out there. You can use it for animation, industrial design, you name it. And it's written in Python, it's written in C and C++, but has a lot of support for Python with scripting. This image has nothing to do with my talk. I just thought it was really cool. It's kind of what you can do in Blender. It's like, animations and shading. It's really cool. It's a really awesome software. It's pretty user-friendly too. And it's open source, totally free. Just grab it. And the way it works is it uses things called meshes, primitive meshes to create geometry. And it's pretty easy to play around with. As you see at the bottom there, it too has a low-code solution. So it's getting, these kind of solutions are pretty popular. You can use low-code, you can use Python scripting, you just use the keystrokes in the UI. It's pretty easy to play around with. But you can't use them immediately for architecture design. That's where the Blender Brim add-on comes in. It's an open source software that was like, hey, it'd be really cool if we could just use Blender to model our building information modeling. Because right now, Blender just meshes and geometries, doesn't do the whole database side of things. But if we took the geometry and meshes and pushed it to the database. So this is the middleman here that can quickly take your model ideas into a software where you can continue working on the database side. And that's what happens when you have the geometry and meshes from the Blender solution and scale it up for a building. And all you're doing here is just taking those meshes, making those shapes. The shapes then have solids. The solids then become loaded with like walls and doors, architectural elements. And then you can at the end see that section of a floor plan that you can then put on a sheet. Very, very fast, very cool. This is kind of like everybody's dream, is to just quickly do something in the software. And I think this is kind of where things are going. They don't want to eat it to get to their awesome ideas. A lot of architects and people in engineering construction, they have to eat it to get to anything nice, and this cuts out a lot of that. And what's really cool is you can combine Blender BIM add-in with the IFC. IFC is like the JSON of the BIM world. It's industry foundation classes, so it's like a non-proprietary. And you can use that to then take the Blender stuff, use this IFC format to then through Blender into these other softwares that you can then load as an exchangeable file. And then you could start editing those in your proprietary BIM software, which is, there's a bunch of them, not just Revit, there's a whole gang of them. And you can do cool stuff like this. You could take your ideas as a giant mesh or a series of meshes, create generative options of a loft of a tower like this, where the base is a bigger shape and the top is a smaller shape. You loft that up so the top and bottom connect. You give it a twist, and before you know it, you get architecture. And this is an amazingly fast way of doing it, all in Blender. You can push it to your other software and work with it. It's very cool stuff. But we're not done yet. There's also this cool Ladybug. And what's cool about Ladybug tools, it's for climate and weather analysis. We're increasingly concerned about how the built environment of any kind is using energy, is good for comfort. And so there's been like a whole spread of solutions, and one of them is Ladybug. And it works with just about any popular geometry engine. It's all written in Python, and you just pip install lbt-ladybug if you want to try it out. It's all free. And what it does is stuff like this. It can help you do solar path analysis. A big old arch tube thing, look at the top there. That's just every position the sun would travel throughout the year in a given latitude. So you can just study a building and figure out what the solar properties were, what it looks like when the sun pops in through your window, what parts of the room at a given time of year are getting sunlight, what aren't, what's a good way to make it a comfortable space, not too much heat, not too cold, so you have to run the heater, just make it efficient. These are the kind of tools and solutions coming around to help people study that and make a better design, better building, a lower energy building that has a better carbon footprint for the environment. And this is just an example of it running in that Dynamo low-code platform, but it runs a lot of other things. So that's what's nice about it. It's very versatile. And it has its friend, Honeybee, which also does similar things. In this case, it does visualization for daylight energy analysis. So you can figure out, highs and lows throughout the year, throughout a day, 24-hour period, a 6-month period, whatever. It gives you some visualizations. They have a whole tool set here. Now you could do this all with the tool sets, but you could also do some cool stuff with generative design and optioneering, as they call it, where you can just use the AI machine learning tools to your advantage to figure out every possible scenario, like different sizes of your room, windows, alignments, what have you, get a bunch of different results and help you kind of determine what is a better set of parameters you can use to move forward with and narrow down your selection so you don't have to do that manually. These are the kind of tools people are using right now for just working on buildings and structures and making sure we have really sound ideas and sound design solutions. And again, all done through tools that you would use from either built on Python or from Python libraries. And that's what's great about it. The future is just going in a direction where Python is going to be a great exchange of data between all these different sets. So you can feed data from all sorts of different model formats and databases, SQL, integrate them through open exchanges to Python, and then from Python, use your different libraries like pandas and what have you to get some analysis out of it so that it's not stuck. That's been kind of the issue with the world I'm in the built environment. Things get stuck in one place or another. They look great until you want to extract data, but this is one way to release that data is through these open standards, accessible coding solutions for people at every stage, and use Python to create some data analysis. And the future moving forward will be, like I mentioned, more data science because there's more interest in how we can use data and things like machine learning to help us understand what's going on in our buildings. They're very complex. You only see the facade, but there's a whole engine of stuff happening under the hood that needs to be studied. Building something, depending on how you look at the reference, it was like 20 and 25% of our carbon footprint comes from buildings. So how do we better design buildings that have a lower carbon impact? IoT, things like MicroPython that can help us develop IoT solutions and digital twin solutions to help us monitor our buildings. Just about every thing is moving in the direction of digital twins for structures small and big. And everything in the building industry is also kind of like 10 years behind the times. So if everything was already IoT kind of kicking off 10 years ago as a big wave, I mean, this watch is an IoT device of my heart. So I'm with it. So we try to see, can we do something like that for the entire structure and get some real good data of are we using too much energy? Is there spaces people aren't going to because it's inconvenient? So maybe like this room, So but anyway. And custom applications. Of course, I saw the demo this morning by Peter Wang of all the cool stuff you can do with Python, PyScript with WebAssembly. And I'm like, well, there you go. So there's all sorts of cool custom applications. I mentioned PyRevit, what have you, earlier. You could just, if you don't want to buy a real robust solution because you don't need it or you don't know what to do with the other tools out there, you can at least try to make your own tools that are a lot more compact or use somebody else's tool set that's to the point and direct solutions for what you want. So this is all the fields that Python can feed into. And shout out to all the open source maintainers out there. Everything I just talked about here was an open source project. Dynamo, even though it's based on a corporate from Autodesk themselves, it's an open source. I could make my own copy, do whatever. They're a great team. I didn't show you Grasshopper this time, but that's a similar looking thing by another corporate sponsor. Blender, of course, completely open source, one of the best examples of open source. PyRevit and all the other tools I showed you. These guys are great. I would not be able to speak to you guys today if it wasn't for these kind of tools. So I always show my appreciation, and of course the Python Software Foundation. They're awesome too. And programming should be fun. That's why I picked Python. JavaScript's great, C#'s great. They're all great, but Python really made me enjoy what I'm doing with architecture and design. They feel like I was hitting a wall of pain, trying to figure out how to debug something. It was way more accessible. So that's why this is why I like this programming language. And just to repeat, Python makes it possible, and this is the beauty of Python. It does so many things great. And if you find interest in any of these things, any of the solutions I've shown you today, consider getting involved with any of these things, those tool sets, or if you're interested in any of these things, you can reach out to me about them, because really at the end of the day, we want more people to be aware of what Python could do, not just in its traditional features, but also the built world. I think if we all kind of put eyes on what we could do for the built environment with automation, coding, data, it'll be a better built environment. Because at this point, it's kind of like everybody eyeballs and uses their intuition to design. But if we had more robust processes and better tools, we get a better version of the future. So it's kind of spreading word. It's to get more involvement in there into Python, into Built World. And this is all the resources for all the stuff I showed you today. On the right is all the links to the different repos and learning libraries for the different software. And on the left there, a special thanks to all the contributors. Guy, he did that Revit API site. Essan for PyRevit, Dimon for Blender Brim, Mustafa for Ladybug, Dynamo team, and Grasshopper team at their companies. I always give a shout to them because I'm really dependent on them. So thanks to them. And thank you so much, guys, for attending my talk. I really appreciate it. I got the QR code right there if you want the link, and I guess it'll be in the video. So if you want to reach out, I'm not hard to find, Tadeh Hakopian. And that's it. I can open up questions, or I can, whatever, here, down the hall. It's up to you guys. Thank you.
Does anyone have any questions that would like to? Otherwise, we can meet the speaker here later, and he can answer any questions, any doubt that you have about the presentation. Oh, you want the mic? Okay, give me a second.
I just wanted to ask you where you think computing for design and architecture is going to go, because Revit and many of the open source tools that you mentioned are sort of hitting Revit, which is a proprietary infrastructure, but you also mentioned IFC, which is the open standard for buildings, and I was wondering what you think about IFC, or which direction it's going to go. We're going to remain proprietary, or do you think this will go fully open source?
My hopes and dreams is that it will go very open source to the point where the proprietary software is optional. You can use it. Maybe I'll give you the better version of the workflows, but if you don't have to use it, you can use the Blender BIM and the IFC and all that to get your work done at a pretty high level. Though it's really, I think the way I would say is the more interest and uses of these open source solutions people are pursuing at the grassroots level, the more the the proprietary software solutions have to respond to that. They have to listen to customer demand, and they fight each other all the time. All these different companies that are they lock you into their thing, and then it's okay, you have to use this. Because even between the different BIM solutions from the companies, they don't like to share anyway. Right. You're locked into their format. So if we had something like an IFC, like a real robust one, which people are getting towards and people want more of, that would accelerate it. I think it's totally possible, but it's got to be people have to be aware at the companies I work at who access the software, who work on these kind of solutions, that they do want more of that open source, so they're not locked in to a vendor. So I think it's just a matter of spreading the word, spreading the knowledge, and the more you spread, and just kind of show these examples of this is what's possible. It's pretty accessible. Then the more it will gain traction. So it's just a matter of grassroots movement in that direction. I do really think that so long as the people want it, the users want it, the companies, the vendors will respond and make it a lot more IFC friendly. But I'm not sure if it'll be IFC as on the what you call let's call it a desktop version of it versus the web. That's where I'm not sure. Would it all be going through the web, because everything's easier on the web exchanges? It's a little more open there versus exporting a file, manipulating that. That's a little more old-fashioned. A lot of friction. So there might be a marriage between the IFC solutions. I believe there is an IFC.js that can help. So it might move in different directions, but I think it will move eventually in the direction of like a better version of IFC if the people want it. I'm optimistic. I'd be optimistic.
So, any other question, please? Today we'll be more than glad to continue the discussion. I'm sorry we ran out of time, but as I said, he will be more than glad to continue the discussion. And thank you, Tadeh, for the great presentation.
Thank you. Thank you all.